Namaste. Hi children, welcome to today's digital class. Today we are going to discuss about trigonometry of 10th class. Children, do you know what is meant by trigonometry? Let us see. Children, trigonometry we are going to divide into three parts. Let me say the first one I am going to call it as tri, the next gonan, the next metri. So, tri means we say it is 3. Similarly, gonan or gonia we call it as the angle. At the same time, metri means measurement, or metron also we call it as measurement. That means, in other words, trigonon means the meaning of triangle. That means, trigonon means we just usually feel it as a triangle, and metron means again we say measurement. That means, a trigonometry is the study of measurement of triangles or three angles we can say. So, once again we see here the meaning of it. So, a branch of mathematics that deals with the relations between the sides and angles of a triangle, we usually call it as a trigonometry. Now, but mostly the trigonometry deals with the right triangles, but what is a right triangle? A right triangle means it is a triangle whose one of the interior angle is a right angle or which is equal to 90 degrees is known as a right angled triangle, isn't it? Now, let us see the diagram or the picture of the right angle. Now, this is the base, you are going to draw a line which is perpendicular to it. Now, let me see the angle between those two lines, how much it is? 90 degrees. Now, if I join this vertices A and C, it is going to look like a right triangle. Now, we will be seeing the complete picture of it. Now, why do we call a 90 degrees angle as a right angle? Shall we see it? Please see. Now, in Latin, angulus rectus means it is the angle between the a upright line or a vertical line. That is the reason rectus mean here we term it as a upright line, right angle. Let us discuss about the right angle, why a right angle is equal to 90 degrees. Now, a ray or a straight line which is in vertical or perpendicular to the baseline, we call it as the upright line or a perpendicular line we can say, is not it. Now, let us use this two perpendicular lines to find what can be the angle of those right angles. Please see. Thus, the angle between any two upright or perpendicular lines or rays we call it as a right angle. We are going to check the angle between those two lines, whether it is a right angle. If it is right angle, to what angle it is equal. So, let us check how right angle is equal to 90 degrees. Now, I am extending that perpendicular line even down. Let me draw a circle like this. Yes, are able to see a complete circle, and this circle when it is being divided by the both the lines, you are able to see there are 4 parts. The first part I have just colored, the second part, the third part, the fourth part. Now, as we divided the complete circle into 4 parts, I will be calling each part as quadrants. I will be calling the first one as Q1, the second one as quadrant 2 Q2, third one quadrant Q3, quadrant Q4. You are able to see it. Now, when you are dividing the circle into 4 different parts, that 2 equal parts, that means what you can say now, what is the angle of a circle here? A complete circle has been divided into 4 quarters, is it right? Now, but a circle is having how many degrees? A circle is equal to 360 degrees. That means, so each quarter of the circle will be equal to 360 by 4, that is how many degrees? 90 degrees. In that mean each quarter is equal to 90 degrees. We have observed that the angle between the upright, that is perpendicular lines, is as equal to the angle of a quarter of the circle, that means the angle in the quadrant. Therefore, what you can say, a right angle is equal to how many degrees? 90 degrees, is it right? Now, what can you say about this perpendicular lines? Is the angle between those two vertical lines is equal to 1 quarter? The other side also, let us check it, both are equal or not. That means what you can say now. So, the angle between those two lines, that is perpendicular and the baseline, is equal to how many degrees? 90 degrees. If it is 90 degrees on right side, what can you say about on left side? It is also 90 degrees. That means what you can say, right angle is equal to how many degrees? 90 degrees. Now, once again we will come back to the concept of trigonometry. Now, here let me say this is a circle, x axis, the y axis, it is the intersection point of x axis and y axis. We usually call it as origin and denoted by O. Now, let me take a point on this circle anywhere on the circle. So, let me take a point P on the circle. Now, when I join this O and P, you will be able to find it is making some angle with the positive x axis in anti-clockwise direction. Now, just now we have dropped a vertical or you can say perpendicular line, and or we can call it as a normal drawn from the P onto x axis, it is P n, which is touching the x axis at n. Similarly, I am going to draw a normal to y axis from P, which is going to touch the y axis at m. Then P m is the distance from y axis, P n is the distance from x axis. O n P m is forming a perfect rectangle, so that the opposite sides are equal, and now you are able to see where O P is the perfect diagonal line. Now, in this case you are able to see P m, instead of representing there, I am showing it on the x axis, that is the distance from y, that is equal to the distance of point P from y axis. I am going to denote it with the O n, so that I am going to call it as a O P n as a right triangle, where O n is denoted by the value x, and similarly P n is denoted by the value y. Now, what could be the O P, which is called as the resultant and denoted by R. Now, you are able to see the clear rectangle, and you are able to see that P n is clearly perpendicular to O n by the symbol right angle symbol there, is it right? So, that we can say O n P is a right angled triangle. What is this? It is the positive angle which we are going to measure in anti-clockwise direction with respect to the x axis, it between the resultant O P and O x. Let me discuss about this right angle. Now, we will be calling here the O n as the base, and similarly the P n we call it as the height, is it right? And here, though we are calling them as height and bases, we have to discuss about them with respect to theta also, but before that let me discuss the third side also. So, I will be calling the third side as the hypotenuse. In a right angle triangle, the side which is opposite to the 90 degrees or right angle is called as the hypotenuse usually. Okay. Now, we are coming back to the base. Now, you are able to see that there are two sides which are associated to the angle theta, that is O n as well as O P, and already O P is said to be hypotenuse. So, I will be calling this O n as the adjacent side, but here we have observed that Pn is not in contact with angle theta, that means it is in opposite side. So, I will be calling this Pn as the opposite side to angle theta. So, with this what happens here, in a right angle triangle we are able to understand which is adjacent, which is opposite, and which side is the hypotenuse. Are you clear? Now, let us discuss about the conditions. So, in trigonometry the basic ratios whenever we take, we start taking with the sin theta. Now, the sine of an angle theta, it can be measured or it can be termed as sin theta is equal to opposite side to angle theta by hypotenuse. So, here the opposite side to angle theta is Pn and the hypotenuse is OP. Now, with the sine we are going to discuss about the one more ratio, that is called as cos theta. Now, cos theta is equal to adjacent side to angle theta by hypotenuse, which is equal to ON by OP. Similarly, the third one we are going to discuss about the angle is, that is tan theta. So, tan theta is equal to opposite side to angle theta by adjacent side to angle theta, which is Pn by On, is it right? And here we have observed that tan theta in relation to the sin theta and cos theta, we can say tan theta is equal to sin theta by cos theta. So, now we are going to see about the sec theta, where sec theta is equal to hypotenuse by adjacent side to angle theta, that means it is OP by ON. So, it is almost all reciprocal to the cos theta, is it right? So, shall we see here? So, where sec theta can be even known as 1 by cos theta. Now, we will go on to get into the another one, that is cosec theta. Cosec theta is equal to hypotenuse by opposite side to the angle theta, that means it is OP by Pn. You are able to see this is like a reciprocal to the sin theta, that means cosec theta can be written as 1 by sin theta, is it right? Now, we are going to see the last, the sixth one of ratios, that is cot theta. But cot theta is equal to adjacent side to the angle theta by opposite side to angle theta, which is equal to On by Pn. You are able to see this is very clearly reverse to the tan theta, or we can say sin theta by cos theta also we can say. That means, here cot theta is also equal to the 1 by tan theta or cos theta by sin theta. Now, here after this we will just discuss about the different values of these 6 trigonometric ratios. What will be those values trigonometric ratios table. So, the basic or you can say general angles what we take are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees, and some of the important angles like 0 degrees, 30, 45, 60 and 90 for our better calculations. So, I will just show you the what could be the values of sin. So, sin 0 is equal to how much? 0, sin 30 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2, sin 90 is 1. Similarly, when you come to the cos, you will be finding all the ratios getting reversed off. So, sin 0 is 1, 30 root 3 by 2, 45 1 by root 2, 60 degrees 1 by 2, 90 is 0. Now, come to tan, it is always sin by cos. So, you will be able to see here tan 0 is 0 and tan 30 is 1 by root 3, tan 45 is 1, tan 60 is root 3, but we can't define the 1 by 0, that means division with 0 is not possible. So, we generally call it as not defined, that means tan 90 is said to be not defined here, or we call it as infinity. Now, cosec, it is reciprocal of sine values. So, that is the reason the first one cosec 0 is not defined, 30 is 2, 45 is root 2, 60 degrees the reciprocal of root 3 by 2, that is 2 by root 3, that is 1 is equal to 1. Now, similarly come to the sec, this is going to be the reverse order of it, same 1, 2 by root 3, root 2, 2 not defined. So, now we will see about the cot theta. So, cot 0 is not defined and cot 30 degrees is root 3, cot 45 is 1, whereas cot 60 degrees is 1 by root 3. That means, at the same time the last one, that is cot 90 will be equal to 0, the value is how much? 0. So, we will come back to the position of the point. Now, you are able to see that the P is a point on the circumference of the circle. Now, you are able to see that the positions m and n, which are the distances Pm and Pn, are the distances from the y axis as well as x axis respectively. Is that right? Now, as the point P moves up or down on the circumference of the circle, you will be able to observe the changes of the distance from x axis as well as y axis. Now, let us just check once again, is right. Now, this is x value, y value, r resultant, now angle theta. Now, shall I start moving this point P either up or down? So, I prefer to move it down, please see. Now, let me move that point P towards downside. You have observed that the P is as it is. Now, you are able to see that the distance is decreasing from P to N is decreasing, right or wrong. At the same time P to M is increasing. Now, in this case what you can say now, the angle theta whatever is there here, it is also decreasing, right. And now, if I try to move this point till the x axis, you have observed that the completely Pn is vanished and where the Pm is almost all getting coincided with the O and N. That means, what you can say now, Pm is equal to OP. Now, here what could be the angle here? The angle is equal to 0 degrees. Now, let me discuss about it. That means, Pn has decreased and became 0, and therefore, if I try to find out the sin theta value, where sin theta can be written as the opposite by hypotenuse, that is Pn by OP, where already we have discussed that is Pn is equal to 0. Therefore, sin theta is equal to 0 by OP, that means sin 0 value is going to become now 0, is it right? Now, similarly we try to check for the cos also. The On is increasing, is it right? That means, the On is nothing but, in the previous case it is nothing but Pm only. Now, this On as well as Pm both are going to become equal to the radius of the circle, that is On is equal to OP. Therefore, what I can say now, cos theta is equal to On by OP, where On is equal to OP means it is going to become cos 0 degrees is equal to OP by OP, which is equal to 1. So, now we have observed that cos 0 degrees is equal to 1. In the previous case we have observed that sin 0 degrees is equal to 0. Now, we will check about the 90 degrees. Suppose if this point instead of moving down, if it moves up, you are able to see that it is slowly moving up and reaching the final point. Now, at this particular position you are able to see that P, M, N are coinciding, N and O are getting merged away. So, you are left with only P O, is it right? Once again I am going to show both P and M are at the same position, O and N are at the same position. That means, here you are able to see that the angle theta increasing as well as, and it is became the 90 degrees. So, now once again we will check with the sin theta. So, now Pn is equal to how much? OP. So, sin theta is 90 degrees is equal to what you can say now here, Pn by OP, where Pn is equal to OP, that means OP by OP is equal to 1. So, here we are able to say that sin 90 degrees is equal to the value of 1. Now, similarly we discuss about the cos. Now, ON decreases, you have observed that ON has decreased up and became 0, is it right? That means cos 90 degrees values is going to become ON by OP, where ON is equal to 0, that means cos 90 degrees is equal to 0 value, is it right? Children, I hope you understood why sin 0 is 0, cos 0 is 1, sin 90 is 1, cos 90 is 0, is it right? Now, shall we check about the 60 degrees? Yes, let me take an equilateral triangle ABC. Let me say the sides, all the sides are equal to the value A, or let me say A centimeters or A meters or A units, I can say better to say. So, I am just representing here by a small a. So, you are able to see that all the angles are equal. Now, let me draw a perpendicular from BC to A. Now, we have one condition, you are able to see that the BC is getting bisected, see it, that means so that BM and CM both are equal, and we have observed that BC was A in the beginning, right. Now, BM I can call it as A by 2 and CM is also equal to A by 2. Now, you are able to see that there is a right triangle, that is ABM. So, now I am going to take this ABM, but before that let me see what could be these two angles. So, let me see, since both are equal, the 60 degrees has been divided into 30 degrees both, is it right. So, that I am able to see here 30 and here 60. Now, 30 plus 60 is how much? 90 degrees. So, I can call these two angles as complementary angles, that means both are complementary to each other, is it right or wrong. Similarly, the sum of any two angles, if it is equal to 90 degrees, you will call them as complementary angles. So, now shall I start with, now this is the right triangle, you are able to see AB is equal to A, BM is equal to A by 2. Now, what can you say about the AM? So, here let us apply the Pythagoras theorem. AM is equal to root 3 by 2 A. So, we are able to say that here the AM height, which we are calling it as height, is equal to root 3 by 2 A. So, now we start discussing about the trigonometric ratios. Now, sin theta as per the condition, here I can say it is opposite side by hypotenuse. So, which is equal to how much here? AM by AB. Here what is the theta? It is 60 degrees. What is the angle here? It is equal to 60 degrees. Therefore, sin 60 degrees is equal to, what you can say, root 3 by 2 A by A, where AM is equal to how much? Root 3 by 2 A, and where the hypotenuse AB is equal to how much? A. So, if I cancel A on the numerator and in the denominator, I will be getting the value as root 3 by 2. Sin 60 degrees is equal to root 3 by 2. Now, similarly, we check for the cos also. So, cos is equal to adjacent by hypotenuse, cos 60 degrees, I am able to arrive at the ratio as 1 by 2. Now, similarly, let me see about tan, opposite by adjacent. Tan 60 degrees value is equal to root 3 when the angle is 45 degrees. Now, sin theta is equal to same, opposite by hypotenuse, which is equal to AM by AB. So, sin 45 degrees is equal to A by root 2 A, which is equal to how much here? After cutting A's, you will be getting 1 by root 2, that means sin 45 degrees is equal to 1 by root 2. Cos 45 degrees is also equal to how much? Same, A by root 2 A. If you cut A's, you will be getting the answer as 1 by root 2. Now, whereas when you come to the tan of value of 45 degrees, same tan 45 degrees is a by how much? Tan 45 degrees is equal to 1. Let us just have a note. So, usually when we measure the angle, we measure it in degrees. So, we call that system as sexagesimal system. That means, one circle is equal to 360 degrees. The units are degrees here, but at the same time we use another system, that is Indian system, that is called as circular system, where one circle is equal to 2 pi radians, that we are calling it as units are radians. Similarly, another system we call as centesimal system, where one circle is equal to 400 gradients, that means units are gradients. So, let us have the relation between and comparison between them. Now, you see that one circle is equal to 360 degrees, that is 2 pi radians, which is equal to 400 gradients. Now, if I try to divide all the values with a 4, after division with the 4, you will be getting the quarter of value of it. That means 90 degrees is equal to pi by 2 radians, which is equal to 100 gradients. Is it right? So, this is the general comparison which we nowadays we are using it. Now, a small assignment to you children. If sin theta is equal to 12 by 13 and theta is acute, find cos theta. Second question, show that sin theta plus cos theta whole square is equal to 1 plus 2 sin theta into cos theta. At the same time, simplify 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta. You find out what would be the value. Children, I hope you have understood the trigonometric concepts and how the trigonometric ratios can be derived. So, I hope you will be able to solve the textual questions with the help of your teachers. Until the next time, thank you.